Welcome to classes on physical chemistry, and today's class is on electrochemistry, and especially I will emphasize upon Nernst equation, how to write Nernst equation. And in my last class I mentioned cells, batteries and primary cell and all these things. And very short way I am just briefing up of the last class content, and where I didn't give any figure for the time point of view. So in the primary cell I gave you details, the cathode and anode reactions and Daniell cell and Lachlan cells. This is dry cell, this is dry cell, and mercury cell. All are the primary cell. And it is very easy to keep it in your mind if you know the figure diagram. If you can draw the diagram perfectly, you can write all other things. So you see, this is voltaic cell, type of the primary cell, where zinc and copper oxidation occurs in zinc, copper is the reduction occurs, negative and positive, and anode is zinc, cathode is copper, and electrolyte is sulfuric acid, H2S4. Am I right? Dilute sulfuric acid. So whenever you know these things, then you can write oxidation reaction, redox reactions, and electrolytes, and also you can write the overall reaction. Next one is Daniell cell. Very important, very often asked to write the Nernst equation for Daniell cell. So in Daniell cell, there is two container where there is two salt solution, zinc sulfate and zinc strip dipped in it, copper sulfate and copper strip it is dipped in it, and zinc in oxidation occurs. It is negative, it is positive, it is U-tube like shape, that is U-tube like apparatus, which is nothing but breeze. BRIT is breeze, and today I will tell you the function of the breeze, and this is the outward connection. Here zinc is anode and cathode is copper electrolyte, copper sulfate and zinc sulfate in two different container. And Lachlan cells, it is dry cell. Lachlan cells is a dry cell, and it is a bit different, and you should keep it in your mind. There is graphite rod, and this is graphite rod, and manganese oxide plus copper is inside this, and outside electrolytes is ammonium chloride and zinc chloride. And that graphite rod is plus, and here zinc is minus. So from yourself you can write cathode is, anode is zinc and cathode is this, and mixture is MnO2 plus C, and here electrolyte is ammonium chloride and zinc chloride. Now one of the things I didn't mention in the last class, why zinc chloride is used. Ammonium chloride in the reaction I gave you that in from ammonium chloride NH4 positive cation takes part in the reaction and becomes ammonia NH3. So why zinc chloride is used? It is very simple. Zinc chloride is used in order to minimize the produced ammonia in the reaction. Ammonia is in gaseous form, and for which the pressure increase. Pressure inside the dry cell increase. If this is not consumed or not diminished or not reduced by volume, then there is a chances of blasting of the shell. It may burst out. Am I right? So zinc chloride is added with this one, that gives zinc a complex like this, and that helps reducing ammonia produced in the reaction, so that there is no bursting out of the cell. This is the use of zinc chloride in the electrolyte mixture. And ammonium chloride is also already used as NH4 positive to give you ammonia in the reaction I have shown you, and that is the function of zinc chloride. Next one is mercury cell. Mercury cell is zinc rod is here, and there is electrolyte is a paste of potassium hydroxide and zinc oxide, and here anode is zinc and C is mercury oxide, and electrolyte is potassium hydroxide plus zinc oxide. In mercury cell, voltage probably this remain constant throughout the life, constant throughout the cell life as potassium hydroxide is not consumed in the reaction. This is the reason it gives a constant voltage consumed in the reaction. These things are important only because very often statement types of question comes, and if you have the knowledge you can answer these things, otherwise you can't. And this is all about this, but is filled with So first of all, let me explain. The solid bridge very often question asked in the entrance exams, also in the class exam. The what does solid bridge contains? It is filled with KCl, KNO3, ammonium nitrate, agar agar. It is a plant solution. It is a plant extracts taken, and it is fused inside the salt U-shaped salt bridge. And what is the function? First of all, it connects the two half shell. Number one. Number two, it prevents the transfer and diffusion from diffusion of solution from one half cell to another. It prevents. Number two, it keep the solution of two half cell electrically neutral. Means if sometimes in one cell there is excess of ions, then with the help of these ionic substances in the salt bridge, it's neutralized the excess ions formed in any one of the half cell. That's why it keep the solution of the two half cell electrical neutral. And last one is KCl. KCl may not be used if there is any silver in the cell. If the cell there is any silver electrodes or anything silver is in any half of the cell, there is silver, it is not used. KCl is not used because KCl reacts with silver to give HCl, and HCl precipitate out. So your mechanism stops here. It will not further proceed. Sometimes very often tricky question asks that in the solid KCl is not used when in the any half of the cell reaction cell setup if there is any silver, because silver can react with KCl to give you HCl and it is precipitated out. This is the reason. So electrochemical cell, already we have seen there is some chemical reactions occurs, and due to these chemical reactions current appears, currents produced. So from chemical reaction current produces electrochemical cells. So electrochemical cells, for your understanding, let me tell you something in a very short manner. You can keep it in your mind. Left, right. So in a very short way, how to keep all these things in your mind in a diagrammatic way, I have shown you. Electrochemical cell is consist of three part. One part is left hand side part, other part is right hand side part, and mid part is the salt bridge. Here there is zinc sulfate, here there is copper sulfate, here is a zinc strip, here is copper strip, here there is U-shaped bridge, and there is connection of current. Am I right? So electron moves from left to right and current moves from right to left. Am I right? So it is known to you. So the left hand side, if there is zinc, so this is cell notation of Daniell cell. Zinc solid becomes zinc 2 positive aqueous by losing electron oxidation occurs. And in the right hand side, copper 2 positive from copper sulfate solution, except these two electron become copper 2s. It is except electron is gained, it is reduction. So in the left hand side, and this is left hand side zinc and right hand side copper. Second one, in left hand side there is oxidation and right hand side there is reduction. Next, left hand side it is negative and right hand side is equal to positive. The left hand side is anode oxidation and right hand side is cathode. So left hand side and right hand side, and in between there is salt bridge. This is electrochemical equivalent, and its representation cell notation is like this. Am I right? Very often question comes. Before starting, Nernst equation, let us first define electrode potential. What is electrode potential? So to understand electrode potential, let us first in a minutes explain electrode potential solution pressure theory of Nernst. What Nernst gave regarding the solution of electrolyte where electrode is dipped. What's happen if in the electrolytic solution there is electrolyte, and there is electrode, that is a metal M. So there are three possibilities occurs when in electrolyte, say it is zinc and zinc sulfate, it is ion in the solution. So there are ions. So ions collide with metal. Ions collide with metal without any change. So first of all, you try to understand the three facts of his and the electrode potential solution pressure theory of Nernst, he tells that ions collide with metal ions in the electrolytic solution. They collide without any change. There may not be any change of any ion. There will not be any change of metal to metal ion, or from this ions to metal. No change. Number one. Number two, metal ion may collide with charges. Metal ion can collide with the ions collide with the collide with ions collide with ions. And if this collision results, if the metal um, release electron, if metal release electron to give metal plus, so metal S release electron N plus, then oxidation occurs. And if same collision occurs where metal in the ions of the metal collides, and in the collision metal accepts electron and deposited, the change occurs by accepting electron, then metal ion plus accept electron give metal solid. This is called reduction. Three type of things occurs. Now what it has the relation of electrode potential, I am telling now. So from the electrode potential solution pressure theory, we have seen that ion may one time metal may lose electron, oxidation occurs, there is a collision, and out of this collision once the metal may lose electron, and they become cations and resides in the solution. And other times the metal ion of the solutions approach the electrodes and accept electron from it, that is gain electron and deposited in it, and thereby two things occur. One is oxidation and reduction. So from that we will define electrode potential. It is the tendency of the electrode to lose, either to lose or gain electron in the solution of its own type. If it is zinc, zinc sulfate. If it is copper, copper sulfate. Solution of the own type. It is the tendency of the electrode to lose or gain electron in the solution of its type is called electrode potential, and it is designated by E. So very simple. Electrode potential of two type. One is oxidation potential, other is reduction potential. If the oxidation occurs, means loss of electron occurs, the potential developed in the half cell reaction is called oxidation potential, and if gain of electron occurs, the potential developed is called reduction potential. Very simple, nothing to explain. So let me define it. It is again very important. You should know the terms, the definition. You keep it in your mind. It is very essential. Sometimes you will get E cell, sometimes you will get E naught cell. You will be confused. So in a half cell, the metal rod M is immersed or suspended in a solution of 1 molar electrolyte at 25 degrees centigrade or 298 Kelvin. It is called standard electrode potential. So in this one, if it is copper sulfate solution is there, and if it is 1 molar and temperature is 25 degrees centigrade or 298 Kelvin, and if there is electrode, then potential developed at this arrangement is called standard electrode potential, and it is denoted by E naught. Simple. Am I clear? Very important things. Very often in questions, in formula, in applying mathematical part of this one, sometimes you will that oxidation potential is given, you have made it minus of this reduction potential. So you should know the term standard oxidation potential of 1/2 cell is equal to minus standard reduction potential, and standard reduction potential 1/2 is always plus reduction potential. If it is oxidation, then it is minus of reduction potential, and if it is standard reduction potential of 1/2 cell is always plus of the reduction potential. For EMF for spontaneity, the cell reaction is feasible if E of cell is positive and del G or del G naught is equal to negative. These two criteria is spontaneity criteria. If again very important criteria, if inert cell or E cell is equal to positive and del G naught equal to negative, then it is spontaneous, and E cell is equal to 0, del is equal to 0, it is in equilibrium, no work will done here in the cell. E cell or equal negative or del naught is equal to positive. If it is negative, if it is positive, it is non-spontaneous. That is, E cell should be positive and del G should be negative, then it is spontaneous. For any other type of condition, either it is equilibrium or it is non-spontaneous. Let me tell some of the important fact in reference electrode. Now the electrode and electrode potential, reference electrode, why there is a question of reference electrode? Reference means you have to take other electron to measure the value of one. Say electrode potential is a term which cannot be which doesn't have any absolute value. An independent way you can't find the value of any uh, electrode potential of any metal. It is always relative. It can be only calculated experimentally with the help of another electrode potential, and the value of which electrode potential is taken as reference should be known. With the help of this known electrode helps to find out the value of unknown electrode potential is called reference electrode. When you take the difference of these two electrodes, we will get the unknown electrode potential of the metal. So why reference electrode is needed? Because electrode potential is a not absolute value of any metal. It cannot be calculated independently. So we require to find the value of the electrode potential of one metal with the help of another electrode metal, which electrode of metal with of which it has electrode, and its value should be known. When we calculate these two value, we will take out the difference, and with the help of the value of difference value, we can find out the unknown value of the electrode potential which is taken experimentally to be calculated out. So reference electrode is needed because its value of electrode potential is not permanent. We require to find out the electrode potential of unknown electrode with the help of a known or referred electrode whose value is known. Am I right? And that's why it is a question of reference electrode is given in your textbook. Now, a lots of reference electrodes are mentioned. I will take only two or three types: gas in half cell reaction, or metal and metal in half cell reaction, or calomel electrodes. So, gas in metal here is platinum and hydrogen gas is taken and it is transformed into this T. And this is very simple. This platinum, the representation is this. Platinum is non-reactive metal. So what we'll do here, half of gas that will convert into is positive amide. This is the reaction. Now here what's happened? Here simple silver solids becomes silver positive. Am I right? This is solid, this is a positive in aqueous solution. Am I right? This is metal, and that of platinum Hg2C2, where twice Hg plus twice Cl2 gives you twice Hg2 plus twice electron. So this is the reactions of this one is Ag2 means chlorine 2 negative. This chlorine 2 negative with Ag, we get Ag2Cl2. You give it liquid and it is aqueous, it is solid. So Very often question from calomel electrodes and its reactions asked in the exam. So you please learn, this is very simple, reference electrode and their reactions. I have taken very few so that you can very easily learn to understand the main fact. Potential of electrode as calculated by Nernst is derived from the reduction reaction where electrons are accepted or gained by the metal ion. Metal N ion, N electron gives you metal solid in aqueous solution. So what's happened? Another I have forgotten. E naught of cell is equal to E of right minus E of left. One thing you please keep it in your mind. We'll use this factor here. So he tells so see, very simple. You should know the terms and very easily you can understand. Last equation, E of cell is equal to inner cell. So whenever the reaction is like this, so there is a reduction and there is oxidation, and this is reduced and this is oxidized. Always reduced part right hand side is above and oxidized part is below. So the representation is E of cell is equal to N of cell 2.303 RT NF log MS, right, divided by a concentration of Mn plus. This is Nernst equation where E of cell is equal to potential of electrode at any concentration. We don't know at a given concentration. E naught cell is the potential of electrode at standard condition at 25 degrees centigrade to 98 degree centigrade, 1 molar cell solution, and R is equal to gas constant 8.314 joule per Kelvin per mole. N is equal to number of the electron involved in the reaction. Number of the electron involved is equal to N, and F is equal to Faraday 96500 coulomb. M of S equal to concentration of metal already deposited in the electrode, and Mn plus is the concentration of the new of the metal in the electrolytic solution. This is all about the information of Nernst equation, which is derived from written from the reduction type of the reaction. Now you see, so you see the expression E of cell equal to E naught cell minus E minus 2.303 RT NF log M concentration MS by concentration M plus 1 transforms into 2.303 and value of R is equal to 8.314 and at T is Kelvin is equal to 298 divided by F. F is equal to 96500. If it is in standard condition, then or doing all this, we can write E of cell is equal to E naught cell minus 0.59 by n equal to log m of s by m of n. Very important, you should keep it in your mind. Now, since concentration of metal deposited is always taken as unity, and we can write E of cell, Nernst equation may also finally be written as E of cell is equal to E naught cell minus 0.0591 n divided by log into 1 by m n positive, where concentration of solid terms, any iron, manganese, any solid is always termed as this. That is, E of cell is equal to E naught cell minus 0.0591 So in above you write reduced part and below you write oxidized part. In a nutshell, you can write E of cell is equal to E naught cell is equal to 0.0591 divided by n log reduced concentration of reduced part divided by concentration of wax part. This is all about Nernst equation. So again, very beautiful things. We record to find out the Nernst equation for the cell EMF where n electron involves. Now we are taking chemical reactions where AA plus BB in reversible sign CC plus DD. So we can write E of cell is equal to E naught of cell equal to 2.30 RT NF log right hand side into left hand side divided by left hand side. So concentration right hand side divided by concentration left hand side. So E of cell, and that part if you again assumed at standard condition 298, so we will calculate this one. We have cell equal to 0.0591 by n equal to log CCD divided by ABB, this. So this is a Nernst equation for cell EMF where n electrons involved. Mind that E naught cell equal to E of cathode minus E of anode or E of right minus E of left, anything you can write. So here we will write Nernst equation for Daniell cell, very important for exam point of view. So what Daniell cell tells? Daniell cell, there is at cathode zinc solid So we know the cathode and anode reaction, and this is overall reaction. and cell notation. Once again I am writing. This is cell notation. Now, what you see that we are asked to write the Nernst equation for Daniell cells, or for to write the Nernst equation for Daniell cell, we should know anode reaction and cathode reaction. It is known to us that there is oxidation occurs in the anode, and Zn(S) becomes Zn2 plus aqueous, and Zn2 plus aqueous plus twice electron. At cathode, we see the copper 2 positive will accept 2 electrons, will give you copper 2s, and overall reaction is Zn(S) plus copper 2 plus 2 electrons will cancel out, Zn2 plus aqueous plus copper s. Am I right? So now the overall reaction, we need overall reaction, because when we will write right hand concentration or right hand part, we have write AA, BB, CC, DD. Am I right? So let's see, E of C is equal to now the question, the concentration of right hand side and concentration of left hand side. That is equal to E naught of cell 2.303 RT and F log. So already we have known the metal already deposited. We have assumed that concentration equal to 1, always equal to 1. So these two concentration is equal to 1 and this is 1. So what 1 it is cancelled out. What we get here is zinc and copper. So again reduced by oxidized form, reduced form by oxidized form, reduced form by oxidized form. So at standard condition, E naught cell here we have written here already this part, the value of this part is equal to this, and here number of electron is 2, because in the whole reaction the involvement of 2 electron occurs. So we have written the Nernst equation for Daniell cell as E naught is of cell equal to E naught cell equal to 0.0591 divided by 2 log concentration of Zn2 plus aqueous divided by concentration copper 2 aqueous. So this is very simple, you can write yourself and you try at home. You can find this one. Before writing this one Nernst equation for any of the Daniell cell or any cell, you should know the cathode and anode reaction, and you should write the overall reaction so that you see the number of the electrons involved in the reaction. Otherwise you can't put the value of n. Am I right? So a reduced form is above and oxidized form is below. So if you write in one steps, no need to write all these things. You write this is reduced form and this is oxidized form, this is above and this is below. Simple. This is above and this is below. You no need to write these two, because these two are already in deposited form. So let us now derive Nernst equation and equilibrium constant. Equilibrium constant is equal to Kc. All of you know. So for the reaction of type AA plus BB equal to CC plus DD, is what equilibrium state is AA plus BB and CC plus DD. So E of cell already we have written. Now we know at equilibrium, CC DD AA BB is equal to Kc. So E of naught of cell is equal to E naught cell minus 2.303 RT N of N log Kc. So this is another important form of E of cell. So again you write E of cell is equal to E naught cell minus 2.303 RT by denominator by NF equal to log Kc. Am I right? We have already written equilibrium condition. So when we have assumed that in equilibrium condition, at equilibrium, so at equilibrium E of cell is equal to 0. There is no moment, there is no work at equilibrium. So there is no E of cell at equilibrium. No work in the cell occurs. Hence, E of cell is equal to 0. So, if E of cell is equal to 0, if this part is equal to 0, then E of cell naught is equal to 2.303 by into NF log Kc. So, we can write, find E naught cell from Nernst equation at equilibrium constant. We have got E of cell is equal to E naught cell equal to 2.303 by NF log Kc, and at equilibrium, if equal to Kc, if this part equal to Kc, then E of cell is equal to 0 because no work is done at equilibrium condition. So if E of cell is equal to 0, the E naught cell is equal to 2.303 NF log Kc. So you have got standard electric potential of a cell is related to 2.303 divided by NF log Kc. It is very important, very important. You please keep it in mind while I will solve the IIT or very other entrance exams questions. You will get all this formula in the mathematics. Mind that it has come from, I'm not showing you from works, it will take a bit time, so no need, you just keep it in your mind, del G naught equal to minus F E naught cell. So already we have written E naught cell is equal to just a bit earlier I have written the relation E naught cell is equal to 2.303 RT by NF log Kc. Am I right? So del G is equal to minus N if E naught cell. So what we can write here, minus NF E naught cell is equal to 2.303 RT NF log Kc. So we can write del G naught is equal to minus NFE equal to log Kc. So it will cancel out. What we get here is 2.303 RT log Kc equal to del G naught. So del G naught is equal to minus 2.303 RT log Kc. So this is all about Nernst equation, and it is correlated electric potential in terms of Gibbs free energy and equilibrium constant. We have learned a lot and we have derived a lot of formulas, and all these formulas are very important for exams also, in entrance exams also, for your class exam point of view. Let me just discuss the last point of today's class is electrochemical series, which is very important and very often maximum of the student cannot find the original fact regarding the electrochemical series. So it is a bit hard, and you try to understand a lots of questions very often asked in the exam. Here it is a very small unit I am talking to, but a lot of questions very often asked in the exam. So minutely follow electrochemical series. What is electrochemical series actually? The arrangement of elements in order of their increasing reduction potential is called electrochemical series. What is reduction potential? What is uh, oxidation potential? Will already explain. So we have written all in terms of reduction potential, means the elements when accepts electron. We have taken lithium at the top and fluorine as the bottom, and everybody of you know lithium has the highest tendency to lose electron, and fluorine has the highest tendency to accept electron. But all we have written is all lithium plus, potassium plus, barium plus, sodium plus, all in terms of reduction potential. Though it has no ability to accept electron, till we have written in reduction, means accept or gain of electron, to understand. So it is reduction potential in terms of this column is written reduction potential in terms of Hall. So here you see the main point is hydrogen. Along with the hydrogen, we have assumed the potential is equal to 0. Its potential is equal to reduction potential value is equal to 0. And above 0, we have taken the negative value, and negative value gradually changes. -3, 2, 2, 2, 2, 2, -1, minus 1, 0.3, 0.3, like this, then 0, then plus 0, plus 0, plus 0, then +1, +2, +2, +2, and +2. Am I right? So here negative value goes on increasing from 0, and from 0 negative positive value goes on increasing. So what's happened? The tendency of lithium to accept electron is the least. So we have seen the increasing strength of reducing agent means least the tendency to accept, more is the tendency to lose. So it is least tendency means it has more tendency to lose. So in terms of losing electron, if you assume, so more is the tendency of losing electron, more is the reduction potential. So lithium has the highest reduction potential. Then you will find potassium, barium, strontium, calcium, sodium, magnesium, aluminium, manganese, zinc, copper, iron, cadmium, copper, nickel, like this. You will get all this. So here from 0 to below, if you go, you will find that copper, iodine, mercury, I have missed out some. I can't write all these things. Chlorine and fluorine has the highest tendency to accept electron. So we see if you move from below to above, from lower point to the above, we see as you go up, so accepting capacity decreases. It is the highest accepting capacity. Fluorine, it will accept highest accepting capacity. So when you will move, accepting capacity will decrease. Accepting capacity decrease means, on the other hand, releasing capacity increases, losing capacity increases. Accepting capacity decreases means losing capacity increases. More is the losing capacity, more is the reduction potential. Minus 1, 0, minus 0, 1, 2, 0, minus 1, minus 2, minus 2, minus 2, minus 3. More is the minus value, more is the losing capacity, less is the accepting capacity. That is, from 0 to above, if we move, all negative, and negative value grows on decreasing. More is the negative value, more is the reduction potential, more is the accepting capacity, means increasing strength of reducing agent. More easily it will accept release electron, means it is a reducing agent. Oxidation process, reverse of oxidation. Lithium plus 1, lithium is equal to lithium plus 1 electron, means it is oxidation, reduce electron. So lithium is a reducing agent. So as you move left to right, from 0 to above, the negative value goes in increasing, means it releasing electron or losing electron capacity increases, means reducing capacity increases. So more and more negative value, more and more releasing capacity or losing capacity increases. So more and more reducing property increases, and oxidizing property is the reverse of these things. I need not to explain. So more is the negative value, more is the releasing capacity, more is the reducing property, more is the electrode potential value. And from 0 to positive, more is the positive value, more is the positive value, more is the positive value, more is the accepting capacity, more is the accepting capacity, less is the reducing property. So accepting and reducing, above this you can explain. More is the releasing capacity, it is more reducing, less oxidizing. So the reducing property increases from left to from 0 to above, means reducing property value, negative value increases, more the negative value, more is the reducing, more is the positive value, more is the oxidizing. This is the simple things, you keep it in your mind. Hope you have followed the class or understood the class at utmost patience. In the next class I will come with a new topic and you will find it more interesting. Thanks a lot for watching the class, and request you to those who have already not subscribed the class, please subscribe the class to get more updated class, because after this class I will start with the entrance solution of questions answer. Thanks a lot for watching the class.